Assalamu alaikum viewers, welcome to my channel, and in today's video we are going to discuss the derivation of cosine law, or we'll try to prove the formula of the cosine law. But just like we discussed the sine law, that how it facilitates the triangles which are either acute angled or obtuse angle, how to figure out the lengths of their sides and how to find out their interior unknown angles. These laws really help us out a lot. So now we are going to derive the formula of the cosine law. For that purpose, we are going to draw here two-dimensional Cartesian plane. Like this. Okay. And I'm going to draw here, you can say, a vector. Okay, so this is the origin, what we say. This is your positive y, that's a negative y. That's a conventional positive x. That's a negative x. And this is our origin 0. And this origin we are going to represent with our at the vertex C. Okay, because this line segment is actually one of the sides of a triangle. Alright, so the coordinates of this vertex C is 0 and 0 because it lies at the origin. So that's it. Okay, so now we are going to draw here the remaining two sides, and I've selected here in this derivation an oblique triangle, okay, an obtuse angle triangle, in other words, what we say. So that's it, and we are going to name the remaining two vertices as A, and this is our B. All right, that's it. That's the interior angle B. You can name it as, you can either call it angle B, also you can name represent it with some other notation like gamma and so forth. This is the integral. I should use beta here. I must use beta here for this interior angle representing vertex B. This beta is too horrible, but this is beta indeed. Okay, and the interior angle C I represented with my gamma, and this is the interior angle A, which I represent as my alpha. Okay, there's no such restriction. I'm just using for enrichment and nothing else. Okay, so alright, so this the vertex, the coordinates of vertex C's origin, and simply if we talk about the coordinates of our vertex B, as it is lying on the x-axis, so definitely the y coordinate is 0, and as far as the x coordinate is concerned, as we know that we always represent the side which is right opposite to a certain vertex, we represent the length of that side with the small letter of that of the corresponding opposite vertex. So I just call it small a. The length of BC line segment, I call it small a. So this represents that the distance from origin to point B is actually a, so the length is a, so it means the x coordinate is a here. That's how I just manage. And the length of this line segment AB is opposite to vertex C, so it is represented by small c. Okay, and the line segment AC is right opposite to vertex B, so its length is going to be represented by small b. Alright, so we have just assigned here the coordinates of B and C here. What about the coordinates of our vertex A? So for that purpose, I think that we should follow projection from this point A on the x-axis. So if I just follow projection here, oh, I need a line option. Okay, so if I just do it like this, so this is the projection, and just touching the x-axis over here. Okay, right perpendicularly, so this is your 90 degrees, alright, and it is touching your x-axis at a certain point. We just represent this point as our D for our convenience. Okay, that's it. Okay, now as far as this this angle is concerned, you see, if you move on, and one thing more, that this angle gamma is representing anti-clockwise, and you know that anti-clockwise angles are always used while performing the trigonometric ratios. So that's it. And this angle that I've just drawn over here, this interior angle of this triangle ADC, this angle is representing a clockwise angle, and it is equals to your 180 minus gamma, because if this is gamma, then this angle is going to be 180 minus gamma. So I should write down here, this is your 180 minus gamma. Okay, that's it, this angle. And this is a clockwise angle, so we are not going to prefer this clockwise angle. We'll prefer the corresponding anti-clockwise angle, which is definitely gamma, because you see, you can understand this thing in a way that we need to find out here the inclination of a certain vector. For example, we always prefer the inclination with respect to the positive x-axis. If this is a certain line segment, if I just use it as a vector, then you see that this is a positive x-axis, and we always represent its inclination with respect to the positive x-axis. So that's this angle is representing its inclination with respect to positive, and this angle, which is 180 minus gamma, it is representing its inclination with respect to the negative x-axis, and it is not preferred, because while performing the trigonometric ratios, you always prefer positive angles, and positive angles are anti-clockwise angle. So if we just try to understand the inclination of this line or vector, which angle you are going to prefer? This angle of inclination is preferred while doing the calculations. That's what I mean to say. Okay, so we are going to prefer here angle gamma while dealing this triangle ADC. Okay, so let me remove this word. Instead of removing, how about if I just simply move upwards a little bit? Okay. Okay. So let me write down here the detail that we extracted here. The coordinates of B are A0. Coordinates of C is 0, 0. Okay. And as far as the coordinates of A are concerned, we have to find it out. So you see what exactly the values of your A, X coordinates and Y coordinates of your point A, what they are, we have to find that thing out. So for that purpose, we just consider here a triangle ADC. The vertex where you're supposed to be having your 90 degrees is always written in the center, so that's what we did. So now we have to find out the length of this side with respect to this angle. Okay, so this angle is equivalent to angle gamma, so we are going to use here positive angle. So we know the hypotenuse, which is B, so we are going to use here cosine of angle gamma. It is equal, and remember, I repeat, we always prefer anti-clockwise positive angle while performing the calculation. So the inclination, which is explaining your AC line segment with respect to the positive x-axis, that angle we are going to consider while doing the calculation. Okay, instead of the anti-clockwise angle. So that's it. So we know that the cosine is equals to adjacent side, which is our x, or which is our CD. So it is x upon hypotenuse, which is our B. So we come to know that the x coordinates equals to B cos gamma. In the same way, you talk about your y coordinates. This is the y, the length from D to A. This length is your y. So sine of gamma is equals to the opposite side, which is your y, upon your hypotenuse. So we come to know that y coordinates of your point A or vertex A is b sine gamma. Okay, so we come to know that the coordinates of your vertex A are b cos gamma and b sine gamma. Alright, so now the vertices are very well cleared. Their coordinates are too clear to us. Now we move forward, and now we are going to consider this big triangle ABD. Alright, so let us highlight this thing with some bright color. So we are going to consider here this big oh, we need a line option. Every time I forgot. So this big triangle from here to here. Okay, but this is a beautiful 90-degree right triangle ADB. So now what we have to do, we can use Pythagoras Theorem, and we are going to find out the length of this hypotenuse AB here. So let us work here. So according to your Pythagoras Theorem, the hypotenuse square is equal to your base square plus perpendicular square. Okay, so AB over here is equals to C, so we are going to represent it with our C square equals to, now what is your BD here? BD is exactly equals to this length A plus this length X, and X was equals to your B cos theta, if you just see. So, and you see this is lying on the negative x-axis, so this value is negative here. So you are adding your A with this negative B cos gamma like that. So it's going to be A plus minus B cos gamma, okay, whole square. So it is going to be therefore A minus B cos gamma whole square. So let us write it directly. Also, you can use here distance formula as well. You simply apply the coordinates of your B and the coordinates of your A. You simply put up the distance formula instead of using Pythagoras theorem. You can do it in that way as well. And as far as this AD is concerned, you see the AD length is y, okay, and y was equals to your B sine gamma, so it is B sine gamma whole square, okay. So now we simply just apply here the common algebraic identity A minus B whole square formula. So it is going to be A square minus 2ab cos gamma plus b square, which is your b cos gamma, so it is going to be b square cos square gamma plus, and this thing is going to be b square sine square gamma. Alright, so this shows that c square is equals to a square minus 2ab cos gamma plus, if I take b square common from these two terms, come to know that it is equals to this. And over here we simply use the basic trigonometric formula that sine square gamma plus cos square gamma is equals to 1. So this thing is 1, so just b square is left here. So c square is equals to a square plus b square. I have arranged it like that, so it is AB cos gamma, and cos gamma was actually your angle C. If you remember, it's your angle C. Okay, so you can represent C square is equals to A square plus B square minus 2AB cos of your angle C. So you can see now that whatever the variable you're supposed to be having at the subject, the angle which is right opposite to this length is written with the cosine. Alright, so keep remember this thing. And the remaining two sides are written in the form, the square of their sum is written over here, and then it is subtracted with 2 times of their individual lengths. Okay, so this is what you call a cosine. In the same way, you can derive the remaining two formulas like that, like this, and like this. So the derivation is quite similar. You can do it, and it's just like what we have done over here. So you can follow the same pattern. For your richness, you can manage these two derivations, which are accordingly so performed. Now, one thing more, that if you can also give it a secondary appearance to these formulas. Like if I just pick up this box formula and I can rewrite it like this. Like if I swap these values, okay, and thus this shows that cosine of angle C, if the 3 sides lengths are known, then the corresponding angle can easily be determined by using this format. Instead of swapping the numbers here and there after calculation, you can use this shortcut and you can substitute your values and you will get your answer. So that's how we do. Okay, so it's just a derivation. I hope it's clear, and if you find this video helpful, if the concept is clear, then do subscribe my channel and hit on the like and share this video as much as you can, and do write your feedback in the comment box. I'll see you in the future with more helpful videos. So just take good care of yourself and practice well, score good. Allah Hafiz.